Good morning. Today we will learn addition of vectors. So we will consider different kinds of addition of vectors, and also we will see the subtraction of vectors along with that. Before going to addition of vectors, I would like to note about a few different types of vectors which often occurs when we solve problems related to addition of vectors. So let me introduce the position vector. From the name itself, you can tell that this must be dealing with the position of a particular vector. For example, if you have an object on this plane of the whiteboard at a point P, then we can represent that using a vector considering x and y axis. And if you consider the origin as O, and if you draw a vector from the origin to the point P, you call this the position vector. So a vector that shows the position of an object is called the position vector. It can be represented as vector of P, as the letter suggests, or conventionally we use the letter R to represent the position vector. Now if this point P is at a distance x along the x-axis, at a distance y along the y-axis, then you can represent this in the coordinate system. You have a unit vector in the x direction, I cap, right? And unit vector in the y direction, j cap. So you can also write this vector as the sum of two vectors. So if this is vector having magnitude x and in the direction x, in the x-axis, I can represent this as xi cap. That is magnitude x and in the direction of the x-axis shown by the unit vector I. And you can represent this vector which is in the y direction having magnitude y as y j cap, because j cap represents unit vector along the y direction. So position vector often come across when we solve problems and all related to the addition of vectors. So this is how we represent the position of a vector. Suppose a particle is here at this point, not on the plane of the whiteboard, it's outside the plane of the whiteboard. Then I will require the x-axis, y-axis, and also z-axis coming out. So when you take the left-hand coordinate system, it's like this. So x-axis, y-axis, and z-axis. So let me try to draw that. It will not be perfect. So y-axis, and suppose you have a z-axis here. Now this is the origin. So you have a point P here, making a distance x along the x-axis, along the y-axis. I'm drawing this slanted because this point is not on the whiteboard. It's coming out. It's outside the whiteboard. So I'm drawing here. And when I consider along the z-axis, it has gone through a distance z. Then I can represent this vector, position vector OP, as equal to, again we usually represent conventionally with the letter R, as equal to xi plus yj plus zk. So this is the usual representation of a position vector. Is this clear? How we represent a position vector, which means position of an object in xy plane, along the plane, or in 3 dimension, x, y, and z direction. This is how we usually represent the position of a vector. Is this clear to you? Is this clear to you?
Yes, teacher.
Okay. Now let me introduce another kind of vector which
yes, teacher, it's clear.
Okay, which often come across, which is called the displacement vector. What is meant by displacement? What is meant by displacement? Displacement means change in position. Suppose I have an object at a point P. After some times, it moved to a point Q. So I can represent in the plane with axis X and Y, this as the origin, the position vector of the particle initially, OP. I represent that as Ri. Ri means initial position of the particle. Now, after some times, it moved to a point Q. So, the position of the particle or the final position of the particle is represented by Rf. Now, while going from P to Q, it moved from P to Q. So, this line represents the displacement vector. Conventionally, we represent it by delta R. And vector delta R is equal to the final position vector minus the initial position vector. Note, in your textbook, this direction is shown wrong. It should be from P to Q. Okay. So, if this is the initial position and this is the final position, so the displacement will be final position minus initial position. So, this concept of displacement should be clear to you. Always it should be taken as the final position minus initial position, and it is usually represented as a vector delta R starting from the initial point ending at the final point. And when you do calculations, you have to take the final position vector first minus the initial position. Is this clear to you what is meant by displacement vector? Is it clear?
Yes, teacher.
Now, another kind of vector which I would like to mention is the reciprocal. Reciprocal vector. Suppose two vectors have the same direction, but the magnitude of one of them is the reciprocal of the other. We call them reciprocal vectors. For example, I have a vector A which is in the x direction, which lies along the x-axis, and I can write it as equal to A is equal to phi I. Phi is the magnitude of the vector and it's along the x direction. So I have represented as phi I, a horizontal direction. So this is a vector. Now if I have another vector B having a magnitude 1 by phi, but in the same direction, then I can say that A and B are reciprocal vectors. So reciprocal vectors means vectors having the same direction, but their magnitude will be reciprocals. So is this clear to you, the three types of vectors?
Yes, teacher.
Okay, now let us go to addition of vectors. Addition, and we will discuss along with that subtraction of vectors. So let me write addition of vector. Addition of vectors and subtraction of vectors are similar because it's just changing the sign or the direction. Addition of vectors. Now, when we add two scalar quantities, you can add that just like numbers. For example, I have time 3 seconds and 4 seconds. You can just add them, like 3 plus 4 is equal to 7 seconds. So addition of scalar quantities just like addition of numbers. But you cannot add two vector quantities just like numbers because they have got direction. Now today we will see 3 different laws by which you can add two vectors. So I'll go a little bit faster. Let us first consider the triangle law of addition. Triangle law of vector addition. So according to triangle law, suppose you have a vector A and you have another vector B. Then you have to keep the tail of the second vector at the head of the first vector. This part is called the tail and this is called the head. So I have another vector B in this direction. So I am keeping the tail of the second vector at the head of the first vector, and this is like this. And the resultant, usually the sum of two vectors are called resultant. So the resultant is obtained by drawing a vector from the tail of the first vector to the head of the second vector. So this is equal to R. R is equal to A plus B. So this is triangle law of vector addition because we end up in a triangle. So how will you state triangle law of vector addition? You have to tell that keep the tail of the second vector at the head of the first vector and draw a vector from the tail of the first vector to the head of the second vector. Then we will get the resultant or the sum of two vectors. This is called the triangle law of vector addition. Now suppose we need to subtract the same vectors. What we require is A minus B. Suppose we require A minus B. It's easy. You just have to add the negative of B. That is B taken in the opposite direction. So you have to add to vector A minus B. So the same vector B taken in the opposite direction. Let us see how it will end up. So this is equal to C. Suppose vector C. I have vector A here. Now B is in this direction, right? But I have to take minus B. And I have to keep it at the head of the first vector. So minus B will be of the same magnitude but of opposite direction. So this will be vector B in the opposite direction. So this is minus B. Now to add them, you have to start from the tail of the first vector and end at the head of the second vector. So this is vector C, which is A plus minus B or A minus B will give you vector C. Are they same, vector R and vector C? No, they are not same. Okay, so when you add or subtract vectors, you end up with different results. You can also remember this easily by considering. So when we start from vector A, the beginning, we go in this order. A in the order of B, but the resultant will be in the opposite order. See, we go from A to minus B in order, the resultant will be in the opposite order. Is this clear to you? Addition of vectors using triangle law?
Yes, teacher.
Okay, so I'm going a little bit faster because this is revision. We are just reviewing what we have already learned. Now, the second one is polygon law. What is meant by polygon? Polygon means many-sided. If you are adding more than two vectors, suppose I have to add many vectors like vector A plus vector B plus vector C plus vector D is equal to what? Okay, there can be as many vectors as possible. So what we have to do is draw the first vector. Suppose this is vector A. Now I have vector B. So keep the tail of the second vector at the head of the first vector, then tail of the third vector at the head of the second vector. So vector C I am drawing like this, vector C. Now the tail of the fourth vector at the head of the third vector. So we are going in order, see, going in order. So can I end from where to where? From where to where should I end? From A to D or from D to A?
A to D.
Yes, you have to end it in the reverse direction. So this will be the resultant of all vectors. So this is vector R. Now this looks like a polygon, hence the name Polygon Law of Addition of Vectors. Now I would like to take another example, vector P plus Q plus R plus S will give you vector C, suppose. This is what I want to do. In that case, I just want to show you that it may not always become a loop like this, which looks like this. For example, if vector P is this, and you have vector Q this one, and you have vector R this one, and you have vector S this one. Then how will you draw vector C? Vector C should be from the starting point to the ending point, taken in the opposite direction. So it need not be always like this. It can be in any shape. It can cross over. It doesn't matter. Still, what you have to do is all the vectors which we are adding, you have to take in order, and end the resultant will be taken in the opposite direction, or the opposite order, or the different order. Is that clear to you? Polygon law?
Yes, teacher.
Okay. Now let me go to the last law, which we call the parallelogram law. The third law, which is called the parallelogram law. What is meant by a parallelogram? What is a parallelogram?
Opposite sides are equal.
Opposite sides are equal. For rectangle also, opposite sides are equal. Opposite sides are equal and the angle between them may not be 90 degrees. For rectangle, the angle between two sides will be 90. Parallelogram, it need not be so. So opposite sides are equal, that's fine. Now, in both of these laws, triangle law and polygon law, we connected the tail of one vector with the head of another vector. Tail of one vector with the head. So, and finally, we took from the tail of the first vector to the head of the last vector. So, these two laws are called head to tail. Head to tail. Okay. So, whenever you come across a situation where the head of a vector and the tail of a vector are touching each other, then you have to use either the triangle law or the polygon law. But if you find this situation where the tail of one vector is touching the tail of another vector, you have to use the parallelogram law. So parallelogram law you can otherwise remember as tail to tail. Even if it is head to head, you can use the parallelogram law. So that is the two different situations. Often I find that the students get confused where to use triangle law and where to use parallelogram law. If the tails or the heads are touching each other, you have to use the parallelogram law. And if the head and tail are touching each other for in a diagram, then you have to use the triangle law. So let's see what is meant by parallelogram law. Parallelogram law states that if two arms of a parallelogram forms two vectors, then their resultant is the diagonal drawn in that parallelogram. For example, I have a vector A and another vector B. See, now I'm not drawing here, not head to tail. I'm drawing tail to tail. So this is suppose vector B. Okay. So I have a vector A and vector B. So how I will do that? I have to complete the parallelogram. For that, I will draw a vector parallel to this vector A and having the same length. So I will draw one here. Then I have to draw vector B, which is parallel and of the same length. I will draw one here. So the parallelogram gets closed and then the resultant starting from this point, a diagonal drawn to the other end. So this will give you the resultant vector. So this is how you use the parallelogram law. So you have to complete the parallelogram and then draw the resultant. Then you will get the resultant of these vectors. Is this clear to you how parallelogram law works?
Yes, teacher.
Okay, now we will use this idea of parallelogram law and get an expression for the addition of any two vectors, how to find the magnitude and direction. All these cases, what we did was we just draw the diagram. So we geometrically represented the addition of these vectors. But generally, if you know two vectors, their magnitudes and the angle between them, how to find the magnitude and direction of the resultant vector. That is always required, right? How can we represent the vector? Not always with a diagram. We need to represent a vector with its magnitude and direction. So we are going to derive an expression that will show you how to find the magnitude and direction of any two vectors having an angle theta between them. So for that, I will use the parallelogram law. And always I was taking angle vector A and vector B. Now I will take vector P. Suppose I have a vector P and a vector Q. Okay, vector P and vector Q. This vector has magnitude P. This vector has magnitude Q. Now, I know that in order to get the resultant P plus Q, I have to complete the parallelogram taking a line parallel and equal in magnitude to this one. And then taking from here a line which is parallel and equal in magnitude to Q. So I have completed the parallelogram. Suppose the angle between these two are alpha. Alpha is the angle between the vectors P and Q. So what we have are two vectors P and Q and having an angle alpha between them. Now we need to find an expression for the magnitude and the direction of the resultant vector R. Okay, so let us see how it is done. For that, let me name this parallelogram starting from the origin O, A. Let vector OA represented by vector P and OB represented by vector Q, and then OAB, let me mark this point as C. So I have noted this down. In order to derive an expression, let me draw a perpendicular line from here and connecting it at this point, and let me mark it as, okay, C is already there, so D. Now look at this diagram. See, this is line, the same line, right? OA and AD are in the same direction. And we have OB and AC are in the same direction. So what will be this angle? OA and OB.
Alpha.
Yes, this angle also will be equal to alpha. Now, we know that the resultant vector R from here, if I take, we need to get the magnitude of R, right? So for that, let me consider triangle, this triangle OCD. Triangle OCD. This is a right triangle because this angle is 90 degree. I have drawn a perpendicular here to AD. So this is 90 degrees. So I have a right triangle where the hypotenuse is OC. So I can represent for this triangle OC squared is equal to base squared plus altitude squared. That is OD squared plus CD squared. Right? If you have any confusion, stop me in between, okay? So I have OD and CD. So OD is the sum of OA, which is P, and AD. So OD, I'm going to write it as OA plus AD, the whole square. OD square, right? Plus CD square. Now, OC I can represent as the magnitude R and OA is P. So let me represent it as R square is equal to P plus AD. I don't know what it is. So AD, the whole square plus CD, the whole square. Now, in order to get expressions for AD and CD, I'm going to consider this triangle ACD. So let me consider triangle ACD. So from triangle ACD, this is again a right triangle. Alpha is the angle here. So I can write that sine alpha. Sine theta means what? Opposite side by hypotenuse. So in this triangle, I have the opposite side CD and hypotenuse is AC, right? So what will be sine alpha? Unmute yourself and speak up. What will be sine alpha from this right triangle? Sine alpha is equal to CD divided by
Opposite by hypotenuse. CD by AD.
AC. So CD by AC. Okay. Now I need CD here, right? So I can write that CD is equal to AC into sine alpha. But AC I know is same as Q. So I can write this as equal to Q sine alpha. Because this Q and this Q are the same. These are Q. And these are P, right? So they are same. So I can write it as Q sine alpha. Got an expression for CD. Now AD I have to find. For that, let me consider cos alpha. What is cos alpha from this triangle? Cos alpha. Adjacent by hypotenuse. What is adjacent
AD by
here?
AC.
Yeah. So AD divided by AC. So I need AD, right? So AD is equal to AC cos alpha. And AC, I know it's Q. So is equal to Q cos alpha. So I got expression for AD and CD. So I'll put both in this equation. So I will get R square is equal to P plus AD is Q cos alpha. Q cos alpha, the whole square plus CD is Q sin alpha. So Q sin alpha, the whole square. Now this is in the form A plus B, the whole square. So which I can write as A square plus 2AB plus B square. So this is equal to R square is equal to P square plus 2PQ cos alpha plus Q square cos square alpha plus Q square sin square alpha. Now Q square is common here, so I'm going to take Q square out. Then I will get sin square alpha plus cos square alpha. What is sin square alpha plus cos square alpha? What is sin square theta plus cos square theta? From trigonometry, you must be knowing that.
1.
1, right. So I'm going to take Q square out. So this is equal to P square plus 2PQ cos alpha plus Q square into sin square plus cos square, which is equal to 1. So I got the expression. R square is equal to P square plus 2PQ cos alpha Q square. Or I can write by taking root over throughout. I can write, I'll be rubbing this part and then addition of vectors and write. I'll rub this part and I'll write here. I got R is equal to root over P square plus Q square plus 2PQ cos alpha. So if you are adding two vectors having magnitude P and Q, having an angle alpha between them, then the resultant will be equal to root over P square plus Q square plus 2PQ cos alpha. So you need to memorize this expression and use it whenever you are adding two vectors having any angle between them. You will get the magnitude this. Now we got the magnitude. Let me also give an expression for the direction. So I'll use the same figure here. Now we got the magnitude of the resultant vector. How will you note or how will you state the direction of the resultant vector? we often state that the direction of the resultant vector as making an angle with the first vector. So suppose this angle is theta. The angle between first vector and the resultant is theta. Now we are going to find out an expression for tan theta. Then if we take the tan inverse of that, you will get theta. Then you can tell that the resultant have this magnitude and it makes an angle theta, whatever the number is, with the first vector. So that is how we usually mention the magnitude of the resultant and the direction. So to find an expression for tan theta, again let me consider this triangle, big triangle ODC. ODC. Okay, so when I take the triangle ODC, I have this as the right triangle. So tan theta or tan theta is equal to opposite side, which is CD, divided by adjacent side, which is OD. And this is equal to, what is CD? I forgot the expression. In the earlier, when we took this triangle, we already got an expression for CD. Remember, this is the opposite side. So sine alpha will be equal to CD by AC, and we wrote it as CD is equal to Q sine alpha. When we consider the previous derivation, do you remember this? CD is equal to Q sine alpha. And what was AD? AD was equal to the adjacent side. So what was AD? Hypotenuse is Q. So what was AD? AD was equal to Q cos alpha. AD is equal to Q cos alpha, right? So Q cos alpha. So I can write here tan theta is equal to, instead of CD, I can write Q sine alpha. Q sine alpha divided by OD is equal to OA plus AD. So OA is P. So P plus AD is equal to Q cos alpha. Q cos alpha. So this is how we will mention the direction of the resultant vector. So you have to memorize these two expressions. What is this? The magnitude of the resultant vector, that is equal to root of P square plus Q square plus 2PQ cos alpha. And what is the magnitude of the resultant vector? It makes an angle theta with the first vector, where theta is given by tan theta is equal to Q sine alpha by P plus Q cos alpha. Is this clear to you, the derivation and the formula?
Yes, teacher.
Okay, so I'll stop it here. The time is over. That's why I did that fast for the direction.